I'm JoanBirman, and I'm a professor of mathematics at Barnard College and at Columbia University. And we're in my office in the mathematics building at Columbia. And what I'd like to tell you a little bit about is braids. And braids are very closely related to knots, and we'll see the connection in a few minutes. So one thing is, you will know one example of a braid, and that's a braid in a person's hair. So here's a picture of it. And of course you can keep going. Well, braids can be used to construct knots or links. For example, I could take this braid, and what I could do is just close up the ends. So there's the braid that we started with. And when you close up the end, what you find is that you have a knot. You might get a link. It might fall apart into some number of components, but in the example I've shown, you get a knot. And here's the braid in a girl's hair, or a person's hair, and it gives a very nice knot when we close it up. This knot is called the figure 8 knot. But of course the question is, if you start out with braids, do you just get a limited class of knots, or do you get them all? And what Alexander showed is that, in fact, you get them all. This was done in 1923, and I want to show you his proof. So I'll give you an example over here. And his example is, again, the figure 8 knot. Now, it doesn't look like this picture of it, but I'm going to show you that it really is. And if I take this to be my future axis, let's see what the problem is. Well, what we're supposed to be doing is traveling around here, and we're supposed to be doing this so that as you go around, and let me start over here, the polar angle is always increasing. So, in fact, I've got it decreasing, but that's all right. So we're going around this way, and everything seems quite all right. And the polar angle is moving along until you get to this little piece. And this little piece here, the thing is turned around, it's going in the wrong direction. And here you see a picture of the same diagram of the figure 8 knot, only now it's tied to a piece of rope on the floor. Well, you step into this picture, and you can step in any place you like, but I'm going to step in right over here. And what I know is that it's this piece of rope that's causing the problem. So Alexander's idea is you just take that little piece, and you know the polar angle function is wrong, and you just take it and you throw it over your head. And now, lo and behold, you pick it up, and what you have is a braid. And there it is, very nice, a closed braid.